Welcome to another episode of Earth is Our Home with Dr. Tom Blaine. Dr. Tom Blaine is an associate professor with the Ohio State University Extension Program. And today we're going to be looking at some interesting things about global warming. So stay tuned. Welcome back to another episode of Earth is Our Home with Dr. Tom Blaine. Dr. Tom Blaine is an associate professor with the Ohio State University Extension Program here in Ohio. Tom, it's a pleasure talking with you.
Great to be on here with you, Patrick. I'm enjoying the series, and I hope that the viewers are gaining a lot out of it.
Over the weekend, I happened to see on one of the news channels that it's dire. We are in dire straits if we don't do something now. And that got me to thinking, we have been like this for 100 years or so. And I want to show you a couple of things, if you don't mind, Tom.
I don't mind at all. Glad to see it.
But as you can see, as we're going through the different timelines, global warming has been on the minds of many individuals. In 1938, Callender argued that CO2 greenhouse gases warming was underway. And the United States has been very actively involved in helping fields of science. And as you look throughout this PowerPoint, you see that we have been in dire straits for many, many years. In 1987, the Montreal Protocol, and basically it was to eliminate ozone depleting substances because we were in dire straits. We had the Kyoto Protocol in 2005. This was a reduction of 5% below CO levels. And we've had the Paris Agreement in 2015. Now, the United States pulled out of that, but many other countries were actively involved in it. So there has been many different things that we as various different country people have been addressing. And I then went and I looked at how we have been improving, or how there are ways to improve our environment, such as better insulation in walls to keep the heat out, green roofs, cool roofs, placement of windows, solar heating, biophilic design, and integrating nature and natural elements and materials. And so I guess what I'm saying to you, Tom, is that we have been living under a lot of dire set of circumstances. Are we really in a dire situation?
I know that you expressed a term, climate alarmism. Why are climatologists and others saying that we have to act now, and raising what many people see as alarm about this? So I would say that despite all those changes, for one thing, despite all those agreements and solar panels and so forth, the trajectory of CO2 concentrations in the atmosphere has resisted all those changes. We're still going up at the same rate of concentration of CO2 in the atmosphere. We're going up the same rate now as we were before. And so the Kyoto, the Paris, all those things that you mentioned, they're agreements written down on paper, and some people have taken some action with solar panels and wind, but none of it's affected CO2 concentrations. They keep going up. They resist change. And so there are a group of people who are expressing what many people call climate alarmism. And I'm going to try to answer that right now in this program. I think this is probably the most important program we've done. Many people who watch my shows and who give me feedback say I'm not an alarmist. Okay. And that's for you to judge or somebody else to judge whether I'm alarmist or not. But what I want to do today is express why so-called alarmists are saying we can't wait any longer. And those agreements, they're saying, don't mean anything if we don't implement hard changes now, not in the future, but now. So currently, there does not appear to be a climate emergency. We look at Earth, despite the fact there are some extreme weather events, if you look at Earth, there just doesn't seem to be a climate emergency right now. Agriculture's doing well. We're feeding more people than we ever have. There's less hunger and starvation now as a percentage of the population than there's ever been in the modern era. Agricultural yields are high. That couldn't be the case if the climate were had worsened. Okay. So despite that, atmospheric concentrations of carbon dioxide are still going up at the same rate they were going up in the 80s, 90s, 2000s. And at this rate, from what climate scientists know about the effect of CO2, within 5 or 6 decades from now, the CO2 concentrations that we have will be sufficient to cause enormous environmental damage. What we do now will determine what concentrations are then. If we start now, we have time to keep the trajectory of CO2 concentrations from entering into the disaster zone. But if we wait until we start seeing the results of significant environmental damage, it will be too late, kind of like shutting the barn door after the cows got out. The danger of waiting or proceeding slowly. And you had asked me once about why do we have to rush? Why can't we proceed slowly? Okay, we've already learned that the reason we have this Earth with the temperature we have, the reason we have a cold house on Earth right now is because the polar regions are Earth's air conditioners. So, 80 million years ago when Tyrannosaurus Rex ruled the Earth, T-Rex ruled the Earth, there were alligators in northern Canada. It was a tropical type environment in northern Canada. The Earth was 18 degrees Fahrenheit warmer than it is now. We can't survive that. T-Rex, that was perfect habitat for T-Rex and Triceratops and all those dinosaurs we love to study about, but it's not our Earth. Anyway, the poles have been extremely cold because warm water from the tropics can't reach them. But temperatures are now rising in the Arctic faster than anywhere in the world. Temperatures in the Antarctic have not risen very much, but that's beginning to change. If we lose our air conditioners, that is the north and south polar cold zones, if the temperatures there rise to the point where they can no longer serve as Earth's air conditioners, and they're well on the way to doing that, the rate of Earth's warming is liable to increase too rapidly for us to adapt. Now, let me go ahead and tell you why some of the folks that people call alarmists are calling for urgent climate action now, not in 2030, not in 2040. Okay, as the polar regions warm, they lose a lot of ice and snow. You mentioned albedo. Okay, when you've got a polar region with lots of ice and snow on the ground, sunlight hits it, reflects back to space, doesn't contribute to the warming of the planet. Now, when you melt some of that ice and snow, Okay. It gets replaced. The surface is now replaced by dark colors, deep ocean blue or green and brown on the land. Now, instead of the light being reflected back, you lose the albedo, it gets brought in. Okay. So that means the earth holds on to more of that heat from the sun and warms further. This is called a positive feedback loop. In other words, when you change something in a system, in this example, when you add CO2 and it causes the temperature to go up a little bit, let's say just 1 degree to 2 degrees Fahrenheit. And then that sets off some other things like loss of albedo in the polar regions because ice and snow have melted. And frankly, not just there. Many of the areas in the Rocky Mountains and the Alps, they're covered with snow year round. But if you have warming there, you will lose albedo there and it will contribute to warming. So what starts out as a 1 to 2 degree Fahrenheit warming could very well become a 3 to 4 degree warming and so on as a result of that feedback. There are other feedback loops, and one that's really vicious is the methane feedback loop. CH4 is methane. Methane is a very potent greenhouse gas. Molecule per molecule, CH4 methane traps a lot more of heat in the atmosphere than CO2 does. There are enormous deposits of methane under the ocean floor, especially in the Arctic. Okay, so if you go up to the Arctic Ocean off the coast of Siberia and northern Alaska, underneath the surface of the bottom, go down to the bottom and scratch the surface, there are lots of methane deposits there that are being kept in by the cool temperatures. If we warm a degree or 2 Fahrenheit from where we are now, there is a lot of reason to believe a lot of that methane will be released and rise to the surface. Think of bubbles, think of fizzing soft drink. You shake it up and all that gas that's down trapped in the water rises to the surface in the form of bubbles and then goes out into the air. It's kind of like that. Also, there are large deposits under the permafrost in places like Siberia. If we start losing that permafrost, again, that's in the high latitudes, we're talking about a positive feedback loop that would be very dangerous. The release of this methane caused by, say, a 2 degree Fahrenheit increase in global temperatures basically would really cause probably a 2 degree Fahrenheit increase, another 2 degree Fahrenheit increase in warming. Many scientists are saying we really can't let that methane escape. That methane needs to stay put. So now we have what we call the 1.5 to 2 degree Celsius dilemma. And I want your viewers to understand this, Patrick. This is what they're really arguing about, why we have to act now. We've got to get emissions to stop growing and even turn negative so that we can get concentrations to stop rising. So they're saying that a lot of positive feedback loops will get triggered if Earth's temperature rises by 1.5 degrees Celsius higher than the pre-industrial temperature, 1.5 degrees. Others say it's more like 2. So there's a debate on whether it's 1.5 or 2. Either way, we're talking about a difference in these groups of a 0.5 degree Celsius, which is only 0.9 of a degree Fahrenheit. Now, we've already raised temperature from the pre-industrial level by a degree Celsius, 1.8 degrees Fahrenheit. It's 1.8 degrees Fahrenheit warmer now than it was prior to industrialization, 1.8 degrees Fahrenheit. And remember, I had told you that throughout civilization, 6,000 years, the temperature of the earth had really only varied within a very small segment of about 2.5 degrees Fahrenheit. Well, we've seen an increase of 1.8 degrees Fahrenheit already, which is 1 degree Celsius. So if you look at what they're warning before these triggers get set off, and remember the triggers were the methane and loss of albedo from melting snow and ice, we only have a 0.5 degree Celsius, or maybe 1 degree Celsius if you go along with the 2 degree folks, before calamity will set in. In other words, with temperatures rising another 3 degrees Celsius, which is 5 degrees Fahrenheit above that. This would be a 9 degree Fahrenheit total increase above the pre-industrial level over the next 100 years, by the early 22nd century, about 100 years from now. 9 degrees Fahrenheit. Now, we already know that going the other way, 9 degrees Fahrenheit, there were mountains of ice throughout much of Ohio, Indiana, Minnesota, down into Iowa, places like that. Kentucky, Tennessee were like Arctic tundra. You cannot have agriculture at all with a 9 degree Fahrenheit cooler. It's a drastically different earth. A 9 degree Fahrenheit warmer, similarly, we could not have agriculture. Agriculture would collapse long before we get to 9 degrees Fahrenheit. That's half the temperature difference. It's only 18 degrees Fahrenheit to where we get to the dinosaurs, where we had tropical climates in Montana, where we had no snow anywhere on earth, where Ohio had the same kind of climate as the Amazon. That's only 18 degrees. 9 degrees puts us into something that's quite like that. We're well on the way to that. Our crops are not, well, none of the flora and fauna on planet Earth evolved in any kind of climate like that, like a 9 degree Fahrenheit increase. It would basically mean a massive extinction event. Anyway, the way we've configured the Earth, transportation, heating and cooling of living and workspaces, agriculture, we've configured the whole Earth to meet our needs. You can get on a plane, fly to Europe. You can get in a car and drive from Ohio down to Mexico. Restaurants all along the way. You know, just we got a world that our ancestors never had, never dreamed of. Okay. But this has been made possible by a lot of things, including dependence on fossil fuels. Okay. That's helped us to configure this world, my world, the world I know and love. I'm not criticizing anybody for engineering this world. On the contrary, I've benefited a lot. I've been to 23 countries. I've been all over the United States, and I've tried all this traveling I've done because of fossil fuels. Okay, so that doesn't change the fact that the way it's looking is that, you know, 1.5 to 2 degrees Celsius above the pre-industrial level, and we're already 1 degree. A lot of climatologists are saying would trigger in feedbacks that would shoot us up beyond disaster. This is the reason why scientists are saying we've got to have urgent action now, because it's like turning a giant ship. You know, we've got this system that's already configured for the use of fossil fuels. We're already committed to burning a lot of fossil fuels in the future because we've got a system that's based on that. We've got agriculture, we've got transportation, okay, and we've got 8 billion mouths to feed. So we're already committed to a large amount of CO2 increase. So climate activists are saying that we've got to start right now.
One question that I have, you're talking 1%, 2%, 5% degrees warmer, etc. I'm not sold on the fact that that will devastate our agriculture. I'm not sold on the fact that as the earth warms up and, granted we lose some of the ice, that we with our technology cannot adapt. We are being very active in keeping the CO2 emissions down when in reality, do we need to? And so, I understand about the increase in the global warming, but how will that affect our agriculture?
Okay, I wanted to make sure that what the climate scientists are saying is that with just another 1 degree Celsius, 1.8 degree Fahrenheit in warming, that it can't stop there. They're arguing that it won't stop there. That once we do that, we're going to hit trigger points, tipping points. And the two that I mentioned are the release of methane and the loss of albedo, and that will send temperatures up another 4 to 5 degrees Fahrenheit over the next 100 years, those feedback loops. So it's not just that we're talking, no, I mean, if Earth only increased another degree Fahrenheit and reached equilibrium there, I agree with you that most agriculture in the United States would still prosper. But the reason that I'm giving you the case today for climate alarmism.
Okay.
What's called climate alarmism. And it's based on the notion that we're only about a little over a degree Fahrenheit. In other words, about a half a degree to 1 degree centigrade below a tipping point that would set off another amount of warming through positive feedbacks. Now, nobody has a crystal ball. I don't have a crystal ball. I can't guarantee you that that's going to happen. But what I'm saying is we're running the risk. It's about risk. It's about running a risk. I don't know. You don't know. Even though these climatologists are making these predictions, they acknowledge they don't know for sure. These are things they're saying are very likely. It's very likely, for example, we're going to have a lot of snow next January in Ohio, but we might not. Might be a mild winter, but it's very likely that we will have a lot of snow. We know that much about the weather. Okay, so we make forecasts. And one question is, what kind of risk are we facing? And they're arguing that the risk is a risk of annihilation of many, many species, because at a 5 degree Fahrenheit increase, even to 9 degree Fahrenheit increase, we would not be able to have our agriculture. Yes, at 1 degree Fahrenheit, we would be fine. Like I say, so far it's increased 1.8 degree Fahrenheit and we're at all-time record yields. But at some point in global temperature increase, those increases in yields will stop and then reverse. And that is what is concerning some of these folks who are saying we have to act now, that if we wait until we have a further buildup of CO2 in the atmosphere, it'll be too late. But if we wait until it's obvious that the damage is there, it's kind of like looking at the iceberg when you're on the Titanic. They were looking at the iceberg when they first saw the iceberg. They were, I believe, a quarter mile away from the iceberg. And so there was no disaster, right? But they turned the ship as hard as they could. And even turning that ship as hard as they could, they barely hit the iceberg, but the damage was enough to doom the ship. Waiting can be dangerous. Had they turned that ship a mile out, they would have survived. But they waited till a quarter mile out, everything was still fine on the way to the iceberg. Once they had made the turn, you could sit there and say, well, everything's fine right now. We're doing okay. But then that moment hits, even though you took some action, and it was disaster. I'm giving you a metaphor for that.
Sure.
But that's what I wanted to give today. I wanted to give that side of the story.
Okay. Hey, we're talking with Dr. Thomas Blaine. He's associate professor with the Ohio State University Extension Program. And Tom, I look forward to our next session because not only have you cleared some things up, but you've also raised some more questions. So I look forward to our next Earth is Our Home.
So do I, Patrick. Thank you.